Hello, this is Mark White with Ascension Hydraulics. Thanks for tuning in. And in this tutorial, I want to better illustrate how hydraulic schematics are meant to be depicted by comparing these schematic symbols to cross-sectional views of real-world hydraulic components. So we basically constructed the same circuit schematically as we have with animated cross-sections here to better illustrate how valves move, how cylinders move, how fluid flows in a hydraulic circuit. So the first part of the tutorial, what I want to do is I want to go over the schematic symbols and I want to talk about each one and then compare it to its animated cross-sectional view here, and we'll do that for each component. And the second part of the tutorial, we're actually going to add the animation to it. That is, we're going to have things move here. We're going to do a couple cycles where we move this, extend out this cylinder and retract it back, and in that process you will see valves shifting, gauges moving, and fluid flowing. So to start off schematically, the first component in our circuit is a fixed displacement pump, and it doesn't just, this schematic symbol does not specify what kind of fixed displacement pump. Could be a piston pump, it could be a gear pump, it could be a vane pump, but if we look at the corresponding animated symbol, it's obviously a gear pump because we can see the two gears meshing. So that's the first component. The second component is a relief valve, a common component used in hydraulic circuits to control and limit pressures. And the way it works is when the pressure from the pump comes, and if there's no path of resistance lower than the setting of this relief valve, what you'll get is you'll get this upstream pressure at 1 will actually move to envision this arrow shifting over to allow flow to go from 1 to 2 into tank. And it's the same thing here. 1 is the inlet in this animated depiction, 2 is the outlet, and if the pressure at 1 is such that it exceeds the spring setting of the relief valve, it'll actually move the pop-it-off land and open up a flow path from 1 to 2. The next component is a 4-port 3-position directional valve. And what does that mean? Well, the 4 ports are P, T, A, and B, and the 3 positions from left to right are this crossover position, where as the arrows indicate, you can envision P going to B and A going back to T. The second position is the center position. In this case, we have P is actually blocked in the center position, but A and B go to T. Another name for that spool configuration is the float position. And our far right position would be P going straight through to A and B coming back to T. So P going to A and B going back to T. And if we look at our cross-section view of the component here, it's the same depiction. In our center position, which is shown here, P, the pressure, goes right up and it's blocked. It can't go anywhere because it's blocked by the spool lands. A, as you can see right there, has space over the land right there where it's going to go around the spool and come back to T, and same with B. B has a space right here because there's no land blocking it. It's going to come right over the spool and go to T.